All right, in this chapter, guys, I'm going to start by a small recap. So in chapter 14, we are concerned with the work and energy, right? So the first part, we are concerned in the principle of work and energy that states that T1, the kinetic energy at state 1, plus the sum of work between 1, the sum of work of all the forces between 1 and 2 is equal to T2, which is the kinetic energy at state 2. And what is the work? As I said, the work is the dot product between the force and the displacement. So it's F times delta S times cosine the angle between them. If I want to find the special, the work of special forces like the weight, for example. So for the weight, I can use both equations, either this one, and in this case, guys, minus W times delta Y. Such equation could be applied whenever I know delta y or I know delta h, which is the height between these two states. All right, so you can either use this equation or you can use plus or minus mg delta s in absolute value cosine the angle between them. All right, cosine that. Right, so guys, in the first version of equation, you know the sign. It's always minus W delta Y, so you don't have to change the sign. While in the second equation, you should predict the sign if it is positive or minus. All right. How to know the sign? If the weight is or if the motion is in the same direction of the weight, then the sign will be positive. If not, then the sign is negative. And I'm going to add another equation, and this is for dependent motion. I'm going to see it later on, all right? For the work of spring force, it's always half ks1 squared minus s2 squared. So it's always half ks1 squared minus s2 squared. And don't forget that s1 is always the current length minus L0. S2 is always the current length of the spring. It's not minus L1, it's minus L0 also, all right? So always, guys, it's minus L0. And what is L0? L0 is the initial length when there is no forces, all right? So let's start by this first problem. It's a very simple problem. In this example, I have a 100 kilogram crate that is subjected to forces as shown. If it is originally at rest, what does this mean? This means, guys, that V0 is equal to 0, right? So it is originally at rest. I need to determine the distance. The distance here means the distance travels. It slides in order to attain a speed of v is equal to 8 meters per second. So I know v1 is equal to 8 meters per second, and I need to find the distance traveled, dt. All right? The coefficient of kinetic friction, since I know the coefficient of kinetic friction, mu k is equal to 0.2, this means that I have a kinetic friction. Now, guys, what I want you to know that dt, the distance traveled based on chapter 12, is equal to delta s if what? If I am sure that the motion is not a changing direction, all right? So if the motion is not a changing direction, then I'm sure that delta s will be equal to dt. It is equal to the distance traveled. Let's take a look to this figure here, to this example. Do you think, guys, that the motion is changing direction? In fact, what is the direction of this motion? It's always to the left. Perfect. Why is it always to the left? Because as you can see, guys, these two forces are pushing this crate to the left, which means, guys, I know that this crate here is always moving to the left. It cannot move to the right. There is no forces that pushes this crate to move to the right. So I know here, guys, that the distance, it is always moving to the left, and the distance traveled will be equal to s, which means if I need to determine the distance it slides in order to attain a speed v is equal to 8 meters per second, I can determine delta s, and this delta s will be equal to the distance traveled. All right. Now, of course, here I have to apply the principle of work and energy that states that T at the first state plus the sum of work between two states is equal to T at the second state. What do you think, guys, T at the first state? Is it T1 or T0? Here, guys, I know V0, which means T here is T0. It's not T1. So I'm doing here, guys, the reciprocal of work and energy between T0 and T1, all right? And I know, guys, that T0 is equal to 0 because, in fact, V0 is equal to 0, all right? So the kinetic energy at state 0 is 0 because it's moving from rest. And I know T1. Why do I know T1, guys? Because I know V. I know V1. So T1 is known, all right? Because I know that V1 is equal to 8. Okay, guys? Now, have to find the sum of work, and I should do this in terms of delta S because this is the question. It is to find delta S. So if I know T1 and I know the sum of work in terms of delta S, I can find delta S. Now, how to find this delta S? Let's do it. What are the work? What are the forces exerted on this crate? In order, guys, to find the sum of work of forces exerted on this crate, I should show what, guys? How to know what are the work done by the forces? I should show. You're listening, guys? Yes, I should show the free body diagram. So what are the forces exerted on this crate? I have the weight. I have the normal force, of course. And I have a frictional force that is always opposite. So this is the frictional force. I have F1, which is equal to 5 Newton. And I have F2, which is equal to 400 Newton. So let's start, guys. I'm going to start by U of F1. I know that the work is F1 dot delta S, which means F1 as delta S times cosine the angle. And since here I know, I'm sure that F1 is doing a positive work, so I'm going to say this as plus F1 times delta S. Now I can remove the absolute value of delta S because, in fact, I know that delta S is positive times cosine 45. All right, I know that this work should be positive. Now, what is UF2? UF2 is also F2 plus F2 because it's also doing the work in the direction of delta S cosine this angle here between F2 and delta S, which is 30. Now, what do you think, guys, is the work of the weight? What do you think is the work of the weight? It's a 0. Why? Because it's perpendicular to the motion. And what about the work of the normal force? It's also 0 because it's perpendicular to the motion. So the work of the weight is equal to the work of the normal force equal to 0. And I still have what? The work of the frictional force. And always, guys, this work is negative. And always, guys, you have that this frictional force is collinear to the motion. So it's collinear, guys, to the motion. Even if the motion here is oblique, the frictional force will be oblique in the opposite direction. Which means, guys, this frictional force will have always an angle of 180 degrees. And that's why it will have a minus work, all right? So it's minus the friction times the distance traveled. So, guys, you should know that if you take a look on the videos, you're going to see, guys, that in the last part of this chapter, the weight and the spring force are always conservative force, which means they only depend on the first and the last state, while the frictional force is not. The frictional force is not a dependent, it is not a conservative force. It depends on the total distance traveled. And that's why I put the total distance traveled. But since here, the total distance traveled is the same as delta S, I can say it's minus FF delta S. Now, what is the frictional force? I know the kinetic constant, so it's minus 0.2 times the normal force times delta S. I don't know the normal force. How can I find the normal force? In fact, I don't need the normal force to find the work because the work of normal force is 0. But I need the normal force to find the work of the frictional force. Now, how can I find the normal force, guys? How can I find the normal force? Who can tell me? How can I find normal force? Quickly, please, guys. By doing the sum of forces in y direction. Perfect, because I know that there is no motion in y direction, then this means that the acceleration is equal to 0 in y direction. And what are the forces in y direction? I have the normal force in positive minus w, the projection of F1 in positive direction, the projection of F2 in negative direction. So I can now, in order to find n, I can do sum of F in y direction is equal to MAY, which is equal to 0, and this means, guys, that I'm gonna have n minus the weight plus F1 sine 45 minus F2 sine 30 is equal to 0, and then I can find the normal force, which is equal to what? 827 Newton. Whenever I know the normal force, I can now apply the principle of work and energy that states, sorry, this is T0 plus the sum of work of the forces between 0 and 1 is equal to T1, and then this means, guys, that minus 0.2 n. Now I can know the work of the frictional force because n is given, is found, sorry, plus 400 delta S cosine 30 plus 500 delta S cosine 45. This is equal to half mv1 squared, and I know that v1 is equal to 8, so you can find delta S now. It's almost 6 meters. Any question, guys? Quickly, please. Any question?